Welcome back, friends. So, as you know that we are in discussion for the Windows programming, and we are discussing about the threads. Okay, we have a lot to discuss. There are a number of things to discuss in the Windows programming related to the threads. Okay, so in the previous video, we discussed about the critical sections, and we saw that how we can synchronize the reader and writer actions using the critical section. And in today's video, which will be smaller compared to the previous video, today I will let you know a few more concepts related to the critical section. Okay, so let me just explore a few more APIs for you. So here I have used critical section object, intercritical section to enter into the critical section, and the same thing has been done in the writer thread. All right, but sometimes it happens that we don't want any thread to wait if someone is working on the critical section, on the same critical section. We just don't want to wait here. We just want to get rid of this place, and uh, later on, when the other thread will be done, or whenever a time slice will elapse, or whenever a decided time stamp will come, then I will check it again whether my critical section is available or not. So in those conditions, rather than using intercritical section, you can use try intercritical section, right? So it's critical section LPCS. So pointer to the critical section, try intercritical section. What does it mean? That it will not wait here. It will just check whether the critical section is available or not. If this is not available, this returns a Boolean value. So we can check here like if not try intercritical section. Okay, then what I will do? I will simply print a message cout not able to get the critical section object. Okay, so this I will print. Else, what I will do? I will simply print the values. Okay, and this leave critical section. Okay, you should not do this. We should do something like this. Bool b is equal to b ret is equal to try intercritical section address of CS, and then if not be ret. If it is not returning any value, then what I will do? This is not needed because you will enter into the critical section, and since you have not acquired any critical section, so you don't need this call as well, right? So in this case, you don't need this call because this call is needed only when you are able to enter into the critical section. So this call will be used only when you are able to acquire it. So this call is only useful here. Leave critical section address of CS. Okay, so that is why it was showing the error here, but it will not show the error here. When I have written this here, it will not show any error. So I hope you understood why I have written here and now why it is not giving me any errors. Because this is the condition when I will be able to acquire the critical section. But if this is not the condition, if this is returning false, then in that case, it means that critical section was not available, so I didn't acquire it. Since I didn't acquire it, so I don't need to call this leave critical section. So even if you will write this call here, then also you will get a warning. You should get a warning, right? Even this will not work. This doesn't make any sense. It should show a warning, but it is not showing. So it should show a warning here, just like earlier it was showing, right? So this is not the good practice when you are using the try intercritical section. But this function you will use very rare. But if you use this, then you need to take care of this. Okay, that's it. So now when my writer will be writing here, then obviously when reader will try to enter into the critical section, it will not get the critical section available, and that is why it should print this message. And we are expecting that this message should be printed. So let me check if this is right or not. Okay, so in this condition, what happened, like reader has got the critical section, because threads, whatever thread will be scheduled, that is decided by the operating system, not by us. And that is why you can see that reader got the time slice first and it all printed 0, right? And that is why in the previous video I was telling you that we often use the critical section objects in conjunction with an event object, right? So as of now, I will try that first this writer thread should start, right? So for that, what I will do, I will just to ensure that I will just place a sleep here for the 500 milliseconds, so that reader will so that writer will be able to get the critical section here. Okay, so let's see. Okay, so now the writing has been started, and you can see that there is a message printed, not able to get the critical section object. This is printing the message that it is not able to get the critical section object, and the thread ID of the writer thread was printed like this, but they all got jumbled up, right? So because of the intercritical section call, so you can see that not able to get the critical section object has been written, and after that it is just waiting for the reader thread to start, but it is not starting because you are done, right? Still this reader thread is waiting that someone will resume me, but it is not happening, and that is why it just printed it and it just returned from here, right? So you need to use this function try intercritical section wisely. Wherever it is needed, then only use it. Otherwise you need to do a lot of fielding to catch this, I mean to hold this in your program. Try intercritical section, you have to do a lot of other calls. You need to take care of all the other places where it can make an impact, right? So you should use it very wisely, and I would suggest that avoid this function. Okay, using this function you should avoid. So better is intercritical section and leave critical section. So let me just close it, let me just put it this way and just do this. Okay, so that was try intercritical section, and let me just do one more thing to show you that what else you need to take care of. I'm just writing intercritical section calls here for the 3 times. Intercritical section address of CS, right? And now here I am just calling leave critical section only once. Then let's see what happens. Let us see if my reader thread will get the time slice or not. I think you might have guessed that what will happen. Our reader thread will not get the time slice. You can see that writing has been stopped, but still reader has not got the time slice. The reason is that as soon as you call intercritical section, then the recursion count, which means the number of times a particular thread has acquired a particular thread has acquired a critical section. Sorry for the wrong word I have used. So it's like you might have seen, let me just open that. That will help me to explain it better. So here you can see that there is a recursion count. This recursion count will be increased. This recursion count will increase with this call. Inside the same function, if you call this intercritical section, then with every call that recursion count will be incremented by 1, and that call should and that value should become 0 before you are able to leave the critical section. And how that will become 0? With every leave critical section call, that value gets decremented. So if you have called thrice intercritical section, then you also need to call the leave critical section thrice. Sorry, I just have to copy this twice. You have to call leave critical section thrice, and then only the leave critical section will be able to leave the critical section, and then you will be able to enter into the reader thread. Okay, so this time we will be able to see that our program is running fine, and reader thread will also get the time slice, and it will be able to print the values which have been placed in the array by the writer thread. Okay, so I hope you are getting the point, and you are getting more confidence with respect to the Windows programming and the synchronization, especially with the critical section. Okay, so this is not that tough, Windows programming with respect to synchronization and inter-process communication. It's just you have to understand it very clearly for the first time. Do it right first time, otherwise you will get it wrong every time. This is the basic principle behind the learning of the concepts related to the Windows programming. I have faced lot many hardships when I started my career. I used to get, you know, I used to get the lessons every day, lectures every day, just for doing silly mistakes. And I used to do those mistakes because the things were not clear and not up to the mark in my mind with respect to the conceptual understanding. So you should not do this, and that is why I am making these videos, right? So let's move ahead with the next concept related to the critical section. Let me just move these, just delete these calls. These are of no use now. Okay, but before that, let us just print it. Just for the curiosity, let us see that what happens when I call this critical section for the 2 times, and after that when I print it, cout endl recursion count. Let us print it. cs dot recursion count. Let me see what happens now. And let us print this recursion count after every leave critical section as well. Okay, so let me just put this call here as well after the first intercritical section call as well. So let's see now what happens. Okay, so you can see recursion count is 1, recursion count is 2. After 2 successive calls, the recursion count is 2 because 2 threads have acquired, right? So now the recursion count is 2, and after that it should start. Okay, I just did like this. Leave critical section, I did this. That is why the reader thread was not getting the time. So now let's see what happens. So after leave critical section, after the last call to leave critical section, you should be able to see the recursion count is 0. So now the recursion count is 2. So after the first leave critical section, the recursion count will be 1, and after the second leave critical section call, the recursion count will be 0. Okay. So it is not printing 0. So it's like minimum value is there. So it will be there. So once you have called this, then only the recursion counter will be, you will be able to see. So I think if you print here, then you will be able to see the recursion count correctly. Okay. Or it may be that the minimum recursion counter is 1, that you can check, right? But that is not that much important. I'm just doing it just for the sake of curiosity. I am also doing this for the first time. I never planned that I will show you, but it's conceptual. So let's see this. Apart from this, let us see one more value. There is one more value which is called the spin count. So let's see what is the spin count and what is the value of spin count and what is the meaning of spin count. Okay, so let us see what will be the spin count here. So just write like this, spin count, and here you just need to print cs dot spin count. Okay, so you just need to control C and control V, and here as well control C, and here it's control V. Okay, but here you cannot expect any change in this value spin count, because the meaning of the spin count is something different than the recursion count. What was recursion count? Let me just put it here. Recursion count. How many times a thread has acquired a critical section object, and to the same number of time you need to release it, i.e., which means you need to just leave the critical section those many times. Okay, this was the recursion count. So you need to check this, you need to note this, right? Because I'm not going to give you a PPT presentation first and then I'm going to explain you. That sometimes doesn't work. So we should learn on the go. And these concepts are really tough. The Windows concepts are really tough, but only in the case you try to learn them by heart. You need to feel them, you need to experience them till you are able to work with them confidently. Okay, so let me just print the spin count as well. There is a default spin count which is decided at the beginning, right? So this is the spin count. You can see that this is the value which is written there to check, and you can see that the values are same. And what does this mean? What does this value mean? Let me just finish it. Okay, this will be finished because I just stopped it, so it will not print all the things. So let me just explain it to you. What is the meaning of spin count? It will always be same. Even after writing, it will be same. And what is the meaning of a spin count, by the way? Spin count means, you might have seen try intercritical section call, right? This was the call. When you will use try intercritical section call, in that case, that spin count has a significance. And what is the significance? That particular count that you were able to see, that particular number, that means that before attempting to check whether the critical section is available or not, how many times my thread will try to find it out, my thread will try to poll it whether my critical section is available or not. Okay, so if I define it, so a spin count is something like the number of times the API try, oh my god, what I'm doing, I'm not sure. Oh, try intercritical section. How many times the API try intercritical section will poll the critical section object to find if it is available, right? Okay, so you can see that this try intercritical section will check, or you can say will poll those many number of times to check whether the critical section object is available or not. So if there are 35,000 something, so this will run a loop of 35,000 iterations to find out if my critical section is available or not. That is a significant time, and that is basically a loss of CPU cycles. I mean, lot of CPU cycles have been used, because in a thread, in a loop, number of CPU cycles are used, right? So that is impacting the performance to some extent, but it may be a bigger impact. It may have a bigger impact. So if you have to use this try intercritical section call, then what you can do, when you are initializing the critical section, rather than calling this function, you can call this function, initialize critical section and spin count. right? So here you will pass the critical section object, and then you will pass the spin count. Okay, what will be the spin count? I am just putting it 100. I am making it smaller, which means that before my critical section, try intercritical section will stop polling, before that this call will poll the critical section object 100 times, means the loop will execute 100 times. If it will poll 100 times, right? So I have just reduced the spin count here, right? So let me just remove this, and now let us just print the value of the spin count. So I will print it only once, right? Let us just remove all the other calls. Let's keep it simple. Just remove this one as well. There is no need, because I have already explained it to you. So just do like this, and let's run it. Okay, so here we go. Okay, so you can see that spin count is 100 now. So this way you can set the spin count by yourself, right? So this time it will execute completely, and it will print every value. Let's just finish it. Okay, so that's done. Okay, so I hope you have got the point related to the critical section objects, and especially these two concepts, recursion count and spin count. Can we make it 0? Let us see. Can we make it 0? You can see that if you set it to 0, it will revert back to the default value, right? So you should avoid these kind of things in your program. So you need to put it like 100 or 1000 or anything. You can do like that, but you should use this function only when you have a scope to use the try intercritical section function. I hope this video is very useful for you, and I would like to request you that you must watch this video at least thrice or minimum twice. After that, you will not do any mistake related to the intercritical section, leave critical section, or you can say the critical section overall for that matter. Just remember these definitions: recursion count, spin count, and how the critical section objects are released, how many times I need to leave, what is the meaning of recursion counter. All those things you must know, right? So watch this video repetitively twice or thrice. Okay, so if you like this video, just share my video, like my channel, subscribe my channel, and press the bell icon as well, so that you can get more videos from me. Okay, so have a nice day. Bye bye, and we will meet soon in the next video. Bye bye, guys.